Hello and welcome back to the A4Q Testing Summit Jubilee Edition. We're coming to you live from Marrakesh, Morocco. In this session, we have the Managing Director of IREB and the IREB General Manager, Stan Booney and Stefan Sturm, and they will be discussing requirements engineering and testing and why you cannot have the one without the other. I hand over to you.
Thank you. So my name is Stan Booney. I'm one of the managing directors of the IREB, and today, in the next 60 minutes, I'm happy to be here in the studio and to present our talk. And with me is Stefan Sturm.
Yes, I'm as well managing director of IREB since about over 10 years. And today, with my colleague Stan, we will address how requirements and engineering and software testing go hand in hand. I need to get through the slides here. In requirements engineering, we have defined about 9 principles for good requirements engineering, and we want to address to you how these requirements engineering principles apply to software testing as well. So let's get into the topic. As I mentioned, we got 9 fundamental principles. First of all, requirements engineering is not a means or an end in itself. It's something which is with value orientation. So it means you are specifying requirements in order to achieve a goal, to specify the needs of stakeholders and to create successful systems. It's not for creating huge piles of documents. We are just going through the principles quite shortly, and then we go into depth. It's about satisfying stakeholders, as I mentioned before. So all about communication. We need some shared understanding in order to deliver good systems. And of course, in order to have this shared understanding as well, we need to know the context where we are operating in. So things can only be understood in context. Then requirements are always bound to problems and solutions, and this is very much intertwined. We go a bit more in detail later on how these things are linked to each other. Validation is key, means a requirement which is not validated is useless. Changes are no incident. We need to be able to adapt changes quickly and in a proper way in our requirements documents. And of course, we need to be innovative. More of the same is simply not enough. And last but not least, and this is the hard thing, it's still systematic and disciplined work. Okay, so let's get into the first principle, and this is about value orientation. The benefit of a requirement is a degree to which it contributes to systems which satisfy the desires and the needs of the stakeholders, and how the requirements reduce the risk and cost when developing systems. So it means you need to find the good enough level to specify requirements in a way that everything is well specified, but not too much, and creating so-called gold-plated requirements. This is a basic principle in requirements engineering. And now it's up to Stan to explain to you how this affects testing.
Okay, so you could ask yourself, hey, why is this, let's say, also a principle that is valuable somehow for testing? So in my experience, it's really necessary to understand that, for sure, requirements are not a means for itself. So they are, let's say, documented because you want to have some kind of qualitative product at the end, and you will have some, let's say, product that's really well working. And testing in general does the same. So a test case itself has no means. Has no means to an end. So if you define a test case, so it's done because you want to have, let's say, a qualitative solution. And especially if you look on requirements, it's quite helpful that you have requirements that are well elaborated and that are not gold-plated, because otherwise you will get somehow lose the focus on what needs to be tested and what is really the things that should be considered in the first step.
Okay, that's about You're already advanced to the next slide. So it's about satisfying stakeholders. This is the second principle. Of course, it's all communication. You need to involve the right people, the relevant stakeholder roles in order to cover all requirements. And all these stakeholders have different needs and viewpoints. Where are you going, Stan? Don't leave me alone. They have different needs and viewpoints, and there might be as well conflicting requirements. And so this means you need to get in touch with the right people, and you need to ensure that you got the right people on board. Stan, how about testing?
So for testing, it's also quite important to know the stakeholders, because imagine if you're, let's say, in a test process, then it's quite good to know if you are testing a certain part of a software and you find a bug or a defect, whom to contact. And I think here it's pretty good to know that you know what are the right stakeholders, so who is requesting this kind of requirement, because I've pretty often experienced the fact that testing will somehow stuck in the process, and then because nobody is really knowing who is owning this requirement and who is knowing the stakeholders behind these requirements. So it's quite easy to get a short contact to them, and also to establish, let's say, where's really the problem? Is the problem in the software, or is the problem maybe also part of the specification? So that's why stakeholders are also, in our point of view, quite important for testing as well.
Yeah, and in fact, the stakeholder list which we create in requirements engineering with the roles, with some kind of attributes you know about these stakeholders, helps a lot in identifying the right people. Is it working?
Now it's working again, yes.
Okay.
Sorry for the inconvenience at screen.
Okay, now coming to the third principle, shared understanding is key. Without a shared understanding, you cannot develop good solution. And requirements engineering is the a way to establish such a shared understanding by talking to people, of course, which creates very often a more implicit shared understanding between team members in agile teams, for example, that they all know each other, they all know their mindsets, etc., the cultural background, and there's a lot of shared understanding in the implicit shared understanding. But as well, you need to have some explicit shared understanding by generating documents, for example, a glossary, where you define the terms and where everybody knows what is meant with a certain term. And even the process of elaborating the glossary creates shared understanding. That's what we experienced recently with the ISTQB, when IREB and ISTQB aligned the glossaries that we needed to discuss. What do you mean when you say defect? It's very important, and this creates explicit shared understanding. And this is an important thing, and it's key for successful system development.
Yes, exactly, Stefan. So, and also I think it's important between requirements engineers and testers to know really what is meant, what is specified in a requirement specification, so that you have that you really know what needs to be tested, and that you understand what is all about. So this means that you know which requirements, for instance, are critical. So are there certain requirements that need to be considered really upfront, and to put more emphasis on, to let's say more test cases on it, more variations to see if this all works out very well. And in my point of view, shared understanding is really one of the most important maybe principles anyhow. And it doesn't matter if you talk about requirements or if you talk about, let's say, requirements and testing, because at the end, if doesn't matter, anyone in this chain does not understand the same of this topic, then you will get lost, and at the end you will get a product that will not work probably.
Yeah. And in fact, this is this very important thing where agile teams try, by being very close together, talking to each other every day, creating this shared understanding. And the link and the interface between requirements and engineering and testing is that important, that the testers know what is meant by this requirement which is specified. So we cannot emphasize enough on this point, shared understanding is very important, and that means that the requirements engineers need to sit at the same table with the testers in order to make clear what is meant. Of course, there's a single bit, a small bit in between, which is the development. They should as well have this shared understanding, but today the topic is requirements and testing, so therefore we skip the developers. Hopefully they know as well what they are doing.
Hopefully.
Hopefully.
Maybe one last point here, and you probably have experienced that it's quite hard to get testers involved as early as possible, because they are anytime under pressure with testing their products. So here it's also important that the test management and all the people around know that, let's say, shared understanding is key to involve these testers early as possible.
To convince people that they are involved early.
Exactly.
Okay. I think that's enough for this one. Things can only be understood in context. I think it's quite obvious that there is a huge difference whether you develop a web shop or a system for an aircraft, safety critical or security issues in here. The way of testing might be different, but this is Stan's topic. The way you approach the requirements is different as well. How much do you need to specify? How detailed do you need to specify? At which point in time you need to be very detailed. And one of the very important tasks is fixing the boundary between your system, which you can specify and generate. You're looking.
No, fine.
Okay, thanks.
Just like your face.
Yeah, great. You need to fix the boundary. You clarify, where does my system end? Where does the boundary end? Which part can I influence? Which is out of scope for me, or not of scope, but I cannot influence. I need to take it as it is. And of course, this boundary needs to fix probably as early as possible, but very likely you cannot fix it in the beginning, because things only once you gain more knowledge, you will experience that the boundary might be at a different position. So the boundary changes over time. And then you need to be aware that things which happen to the system context might have a strong effect to your system. For example, a new standard being published just when you are starting to specify the requirements. This is in the context, but it has an impact on your system, and probably a very strong impact, or a new law is just being put in place. That's for the requirements. Anything for testing left?
Well, I think there's nothing much left because we told so much. But, but anyhow, I think understanding the context, especially for testing, is quite important, because, or maybe especially if you do not have the testing team on site, and if you have the team involved in your context. Because what I've also experienced, if you are working with outsourcing partners, this means you are defining requirements in a company, and you're developing the requirements, but the testing is somehow outsourced in another region, in another company, whatever. Here it's really so important that also these testers understand the context. For sure, it's also a kind of, let's say, shared understanding of the last principle. But I think the context here is quite important. So let's say, developing, as Stefan mentioned, just another website, or am I developing a health system? So that's, let's say, somehow really critical in certain cases. And here it's really important, based on this context, you have another test strategy probably. So you maybe involve the users if you're, for instance, talking about a new website, a new shop that you're developing. But if you're, for instance, creating something for a medical system, for aviation, for other safety critical systems, then maybe you have some other test strategy, and that needs to be considered. That's why understanding the context is so important.
Yeah. And as well, there are lots of interfaces between the system context and your system. Exactly. And you might need to specify dedicated tests for these interfaces. So the testers need to be aware of all these context items.
Absolutely. Especially, just as you mentioned, the interfaces. Also, let's say, for the testing environments, the context is quite important, because dealing with testing environments, you, as a tester, you probably know better than me, it's always a hassle, because testing environments are not available, they are not on the right release, and you have to patch certain stages. You need to have this integration of certain systems. And also here, if you understand the context in the very first step, it's even better, because then you can prepare your systems in a, let's say, upfront way, and not only reactive.
Planning the testing
Exactly.
may be very different for different environments. And if you look at the GDPR, you might not have the data available. You cannot use production data and all these things. If you know about the context, you know about these challenges upfront, and you can prepare your test strategy much better. Okay. So now coming to problems, requirements, and solutions, that this is an intertwined triple. You might think, yeah, we got the problem, let's specify some requirements, and then we build a solution. But it's not always this order where they appear. There might be let's say, ideas by users. I got an idea, could we perhaps do this or that? And then you think about potential solutions, and then you come to the requirements for these solutions. And then once the solution is done, you might see, oh, now things have changed, and the final solution ends up in new requirements, perhaps for the same system or for following systems, where you need to specify again requirements, understand the problem, specify the requirements, build the system. So it's not always problem, requirement, solution. It's intertwined, and it changes all the time. Nevertheless, requirements engineers try to separate the problem space from the solutions, just for thinking purposes. It's easier if you're not focusing too much on solutions already, when you are still working to understand the problem.
Yeah, and for testing, what does it mean? I mean, for testing, I think it's quite clear, because it's about the solution in general. But also here, it's quite important to understand what are the requirements that are based on it, what are the problems that have to be solved. And especially here, depending on a solution, it's maybe really a different way how the solution is tested. So for instance, if you have, let's say, cloud-based system, or a system that is installed on site, let's say, depending on the solution, the test cases are different. There may be additional test cases that need to be considered, and so on. So even if the, let's say, problem in general is solved, or if on the requirements level, this is more or less the same, if the solution is different, test cases need to be adapted, and they have to be considered in a different way. And in addition, what's also quite important, or what's also quite often used, are topics like, let's say, A/B testing, for having a kind of, let's say, to see if there are, let's say, two or more solutions that are maybe variants for solutions, that you can find out what is the best way. So this could be, let's say, a simple website for A/B testing, but this could also be really some kind of implemented application, whatever, to see where you have, let's say, really two ways that are somehow tested. And this is also something I think that's quite important, and it's getting more and more important also, let's say, in the agile way and in the innovative way, because if you're building some, let's say, innovative solutions, then maybe upfront you do not really know what is the best solution. So then here maybe it's also quite helpful to have this, let's say, A/B testing and different test strategies on site.
But this brings me back to the another principle. You need to understand the context. A/B testing can't be done in every context. Then take a safety critical system. You might not want to test the brakes of a car, or whatever, something in an aircraft, by A/B testing. There might be a group which might not be happy with that.
Yeah, absolutely. I mean, all these principles, they are for sure, they are somehow atomic, but they are depending on each other. So, and let's say, if you are looking for a good solution at the end, you should consider all these principles.
Yeah. Okay, then we are to a principle validation is key, where many things come together, because now this is in the validation you will see whether you have had a shared understanding between you and the stakeholders, whether you really have specified what the stakeholders need. Do the requirements really fit their needs, and are they are all these things covered by the requirements? So this is whether you have been value oriented, so means specified enough in the right level of detail and the right things. So, and this is one of the core activities in requirements engineering, to do this validation, to present the requirements to the stakeholders and potentially resolve conflicts where different stakeholders have different views on certain requirements. So this validation task is a very, very important step in requirements engineering. Anything to add for the testers?
Yeah, I think that validation is key. It should be nothing new or spectacular for a tester. I mean, that's why you are doing testing, that you validate if the, let's say, solution fits the requirements of the customer. But I would go a step further. So one thing is, what is really helpful, or what was really helpful in my projects, is, as mentioned already before, to get testers involved quite early, also in the requirements engineering phase. Because if you are, let's say, also validating your requirements, so you have to think, are they clear to the testers? And here it's quite helpful to involve testers also in the kind of review phase. So if you're writing a requirements document, or if you're, let's say, also in an agile part, if you're writing user stories and epics and so on, doesn't matter. So it's so important that the testers are already involved in this review process, because they have so valuable feedback and review comments, because they have completely different view on this, let's say, solution, on this requirements, because they have different topics in mind, from the environments, from data, from whatever, that most of the requirements engineers out there do not consider upfront. And so for me, this was really anytime a big value for, let's say, involving testers quite early. So do you want to say something?
I just thought that this is a clear call to the requirements engineers to
Absolutely.
get the testers involved, because requirements engineers typically think validation is about stakeholder needs and clarifying with the stakeholders whether everything is specified in the right way, but it's much more. It's involving the tester means that you validate your requirements much further in towards let's say getting the tests done, and whether this is testable, whether it's a test data needs to be created, and all these things this is as well part of this validation.
Absolutely, yeah.
So this is what I think very important to the requirements engineers, not only to the tester that they understand about it, but the requirements engineers understand, hey, testers can help me doing a better job here.
Yeah, indeed. I think this is exactly the idea of our session today, to make clear that it doesn't matter if you're a requirements engineer or a tester, that you have to look over the fence, and that you do not say, hey, I'm only the one who's, let's say, creating the requirements, or I'm only the one who's creating the test cases or performing the test cases. This will not work out, at least not in today's, let's say, complex solutions that we have. And that's why our, let's say, claim for each and everyone is to talk to each other, to get involved, to get in touch as early as possible.
Yeah. So now the next one about change. This is typically something where in former times the requirements engineers have been seen as those who do not like change. We don't want to change anything because I have documented everything in great detail. Spent 6 months for that, and so the document is now fixed. You're laughing. There's a baseline. We are not changing anymore. Of course, this is nonsense. Ever since the change has been very important, and there were dedicated means to address change by traceability and all these things. The message is, particularly in agile environments, changes are accident. They are part of the evolution of the system and the solution. And so requirements engineering strives for permitting these requirements to change and providing the right means to track these changes. Of course, too much change is as well a bit of a problem, because if you are changing things too frequent, you will not be able to do the right implementation and the testing, and this is simply too much then. So there's, of course, a certain level you should not extend, but nevertheless, change is welcome for requirements engineering, of course. And for the testers?
I have no idea. We should ask a really professional in testing, but in my point of view, it's also welcome in emphasis for testers the same way as for requirements engineers. I mean, for sure, as I've worked as a requirements engineer, I have completed my entire document of whatever 60, 100 pages, and it was reviewed as what was assigned. It was, let's say, approved. So development has started, and then someone from marketing came around and said, "Whoa, well, some things have changed, and we should do this in another way." And you really, everything is breaking down. You're totally disrupted, and that's how you feel as a requirements engineer. Probably testers feel the same if you say, "Hey, there's a change request." But I think the important thing to understand is that changes happen. It doesn't matter. In each and every project, changes happen. This does not, let's say, is not a reason of incompetencies of each and of anyone. It's just happening because the world is circling around, and so that's why changes are happening. And for testers, you asked me, come to your question. I think it's also important for testers because each and every test case that is already written, or if you have, for instance, some kind of regressions or whatever that are running, that need to be considered. And here it's important that also for, let's say, change requests, requirements engineers and testers, not only requirements engineers and developers or architects, but also testers are working closely together, because only then it could be somehow guaranteed that the test cases are updated with the release, that, for instance, some test automations that have been prepared are available, that the test data is available, because otherwise you will have, let's say, the bug, the update or the change in your software, but your test cases are not well prepared.
So the message is, even if you are not happy about the changes, you need to prepare for them, because they will happen. So exactly. Get prepared for it. Principle 8 is encourage innovation. This is something where we say, as a requirements engineer, in the past, there was a notion that requirements engineers just record what the stakeholders tell them. They write it down and they specify it in a very clear and understandable way. And of course, this is not what a good requirements engineer does. A requirements engineer always tries to find, not only to satisfy the basic needs and find basic features, but they are trying to strive for exciting new things, which give the wow effect for the stakeholders. And therefore, there are a lot of creativity and explorative techniques in requirements, which they could use, the requirements engineers, to enable innovation. Also, plenty of stuff here for requirements engineers.
And even for testers, I think, because if you have, or if you're developing some innovative solutions, so it's also important to be, let's say, have some kind of innovation in your testing process. So, for instance, if you create, or if you're developing a new system with artificial intelligence, or for, let's say, with big data, virtual reality, or whatever, also here you need, let's say, another way of testing. So it's not just some kind of functional test or whatever test that needs to happen. Also here, especially, let's say, with virtual reality or with artificial intelligence, it's quite important that you are, let's say, that you see that also the engine needs to be somehow trained, and based on the, let's say, effort you put in the engine for artificial intelligence, then the tests or the results are getting better and better. And here, in my point of view, it's also a big question in requirements engineering and in testing as well. which part of rules, which part of test data, which part of results are expected from these kinds of solutions. And I had some other findings as well. If you are talking, for instance, if you have some innovative solutions and you say, hey, the company should have one huge big data warehouse that is implemented, and where all this information is stored, then you could, for instance, have a look on your customer data, merge some data, and so on. And here it's quite critical because you need to think about what is, let's say, impacted by GDPR, which test environments do I need, is the test data available as soon as I have created the records in the, let's say, test systems, because usually in the data warehouse, it's only 1 or 2 days later because there's some post-processing that needs to be done. And all these things also need to be considered in your test preparation and your test steps. So this means this kind of innovative solutions also need maybe some kind of rethinking. How could the test be structured? And I have no answer for it because I'm not the expert in testing, but in general, I think this principle is quite clear.
But so that means that you're not using always the same test approach and test cases, but
Exactly.
just try to be innovative in testing in order to improve testing permanently.
Exactly.
Okay, so this was the exciting stuff. Now we're getting to the boring stuff. Systematic and disciplined work. Of course, requirements engineering, you got a tool set and people tend to do all the things all the same. So we collect the requirements, we do interviews, and they have the same requirements engineering process. And the important thing is that a good requirements engineer always configures the RE process in a way that it is well suited for the current situation, and that they do not reuse processes and practices from past projects which might have been successful. Just because they have been successful, they might not fit into the current situation. So this means a requirements engineering process and thinking about this process, what to do, when to do, in which level of detail to do. You cannot say we are doing the agile, we are not specifying. You need to think about, okay, what is the context? How much do we need to specify? How detailed do we need to be at which point in time, going from a rough level to a very fine-grained level? And all these things need to be considered each and every time when you start a new RE task, or even during the current RE task. You might reconsider and reshape your process because you might experience that it does not work. So think carefully, work disciplined and systematically. For the testers?
In my point of view, testers are also working systematically by definition because they have, let's say, a clear structured way of how to do test cases, how to, let's say, validate and verify if a software component is working and if this complete system is working. So I think here it's not far away from requirements engineering, but maybe also, or especially in testing, it's even more important to be a kind of systematic, so you don't make this, let's say, chaotic tests that I may do, or that, let's say, you're doing a kind of user acceptance test with, let's say, different people involved. Maybe this is also a nice way, but the real systematic way of testing is quite important. And in the same way here, as Stefan just mentioned, I think it's the same. For sure, you have, let's say, well-known processes, well-known and, let's say, ways how to set up test cases, how to set up test strategies, and so on. But even here, it doesn't matter if you are, let's say, in a waterfall or moving from waterfall to agile. Also here, you need to consider what is the, let's say, best way to come to my test cases now. Are these epics user stories? How are they, let's say, shuffled? What is really planned in a release? Also here, it's quite important to have a look on your process. So to see how to manage what needs to be done. And this is one of the most important facts in my point of view.
All right, so this has been the 9 principles of requirements engineering and how they apply to testing as well. We got a summary slide for you. We will not read through that one because you already heard it, but if you want to check it out later on, this is the summary. And now we are I think, open for your questions.
Exactly. Maybe one,
Perhaps just
maybe one main point from my side. What was the key of this talk? In my point of view, one major message is, as mentioned already before, that you as a requirements engineer and you as a tester should be, let's say, as close together as possible, that you need to talk to each other, that you need, let's say, if the requirements are defined, that you involve testing people, that if you're, let's say, doing the testing process, that you also ask the requirements engineer for who is the stakeholder who requested this, to not stuck in this process, because otherwise you have this, let's say, ping pong with of tickets with development, going back and forth and back, and this will not, let's say, it's not beneficial for the process at all. And this is at least, I think, one of our main messages today, Stefan.
Yeah.
Right?
So we are strongly advocating for requirements engineers and testers working very close to each other. And it's not by coincidence that we are today at the ISTQB meeting in Marrakesh. So it's not only for having a nice trip, but to meet the right people. And when we talk to these guys, we all know the same stories where requirements are not understood by the testers because they were not clearly enough specified and all these things. So they need to work really closely together. But now the questions, perhaps, if there are any.
We unfortunately do not have any questions at this point, but I thank
Okay.
you so much for your valuable insights into how requirement engineers and testers need to work together to accomplish development goals. I thank you again, and I hope that the two of you have a fantastic afternoon.
Yeah, perfect. Thanks a
Thank
lot.
you.
See you out there.
Bye.
Thank you.